Okay. So it says 3 resistors, R1, R2 and R3 are connected in parallel across the cell. The cell has a negligible internal resistance and electromotive force. E. The principle of conservation. Use the principle of conservation of charge to show that total resistance of the 3 resistors can be found. So principle of conservation of charge. So we know that if you have a total charge coming in here, then conservation of charge says that these 3 things must add up. So from conservation of charge, we know that the Q total must equal Q1 plus Q2 plus Q3. Now we know that current is the rate of flow of charge. So if we have so much charge per second coming in, the amount of charge per second going in up here must equal the amount of charge per second coming out of all 3 of these things. That's a plus. In other words, this is actually the total current is equal to the current 1 plus the current 2 plus the current 3. Okay, so now we know how do we relate current to resistance. Well, there's one equation that we've got this one equation. V is equal to I times R. So I is equal to V over R. Okay, so we're just going to substitute all of this. We've got V total over R total is V1 over R1 plus V2 over R2 plus V3 over R3. Now, in a parallel circuit, in parallel, you know that the 3 voltages are the same. So actually, the V total is equal to the EMF that they've called it, which is also equal to V1, which is also equal to V2, which is also equal to V3. So actually, these voltages are all the same. So that is true. So you've got 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3, which is what is required.